As we continue on with our unit on functions, we'll look today at linear functions and also function notation. Later on in this session, we'll look at being able to graph a function using a table of values and then to be able to interpret that graph. A couple of key terms, and you could actually even pause the video to write these definitions down at the top of your notes page. A linear function is a function that's in the form y equals mx plus b. M and b both are constants, so this would look like y equals 2x plus 1. Later on, we'll find other forms of a linear equation, but for purposes of function, we're going to say a linear function is defined as y equals mx plus b. Function notation is a method of writing a function that indicates that the output is a function of the input. So f of x tells us that we have a function with x as its input. As an example, f of x equals 2x plus 1. One of the things we'll be asked to do is to identify if a function is linear or not. And there's two big things that we're looking at. First is that the highest degree of the exponent is 1, and that there's no variables in the denominator of a fraction. So as a for instance, in example A, f of x equals x squared plus 2x plus 1. This is not linear because it has a higher exponent than 1 on the variable, and you recognize this as a quadratic function. Example B, g of x equals x over x plus 1. This is a variable in the denominator, so not a function, and not a linear function. And in C, h of x equals negative 4, and we may feel like, well, this doesn't look like y equals mx plus b. But we need to keep in mind that x can have 0 as a coefficient. We could write this as h of x equals 0x plus negative 4, so that m is 0, b is negative 4, and both of those are constants, so this would qualify as y equals mx plus b and would be a linear function. One of the first skills we want to look at is the ability to evaluate a function for a given value of x. And remember, right inside that word evaluate, it says value. So f of x equals 4x minus 1, and x equals 3. So in order to do this, we'll write f of x equals 4x minus 1. Then we'll write f of 3, indicating that 3 is our input value. So now 4 times 3 minus 1. 4 times 3 will be 12, minus 1. F of 3 is equal to 11. Next, we want to be able to graph a function, and we're going to use a table of values in order to do this. Obviously, as we move on through this unit, we'll also identify some other methods of being able to graph a function, but for now, we're going to use the table of x and y values. We start with negative 2, negative 1, 0, 1, and 2. These are values for x. So if we substitute in negative 2, 4 times negative 2 is negative 8 minus 1 is negative 9. If we substitute in negative 1, 4 times negative 1, negative 4 minus 1 is negative 5. 4 times 0 is 0 minus 1. That gives us negative 1. 4 times 1 is 4, minus 1 is 3. And 4 times 2, 8, minus 1 is 7. So now we've got 5 ordered pairs. Negative 2, negative 9. Negative 1, negative 5. 0, negative 1. 1, 3, and 2, 7. So let's go ahead and plot these points. So the first point, negative 2, negative 9, is going to be off our grid somewhere down here. 2, 7 is going to live up here somewhere, but out of the 3 points we have, we've got plenty to be able to create our line. Remember, we only need 2 points in a straight edge. So kind of drawing this one in roughly by hand, the graph would look like this. Let's look at one more example, one that works around a word problem. So this sets us up that we're joining a fitness club, and there's a one-time membership fee of $60 and then a monthly fee of $50. And it asks us to write a function that models the total membership cost over time for joining this club. So remember our verbal model. Total cost is $50 times number of months plus 60, which was our sign-up fee. So total cost, and we could let T stand for total cost, is where your equal sign goes. 50, our multiplier, number of months, we can use M plus 60. So T equals 50M plus 60. Now, when we go to graph this, remember when we looked at graphing functions, we were only looking at the first quadrant, 0 for time and 0 for distance, because negative values didn't make sense for that. And similarly, negative values don't make sense for this problem. So we're asked to graph the values for our first month, or first year rather, of cost. So let's go ahead and graph this. We can use months as our X value, and then total cost is our Y. And kind of thinking about what this scale should be. We obviously don't want to let one box equal one. After a month, it's going to cost us $110. And so we know that this is eventually going to end up maybe somewhere in the neighborhood of 1,000. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. If we let each be 50, we'll be up around 600. If we let each equal 100, it'll be a little bit hard to graph our points. So we need to make a decision here on how this is going to end up. So you may decide to go 300 for your scale, or 100 for each box. So now, when we go to graph this, when our input is 0 months, we have a cost of $60 because that was our sign up. A cost, a term of 1 month, our $60 sign up plus the 50, that's 110. 2 months, sign up of 60 plus 100. 3 months, sign up of 60 plus 150. That puts us at about 210. So we can see where our line is going to be. So without benefit of a straight edge, we kind of just ran this by hand. Now, if that's our function for part B, part C is really the value of making this graph. Use your function model to find the cost of the membership for the first year. So as I follow this along, I'm going to be somewhere in the neighborhood of 800. That looks like about 850. That's one way we could do this. Another way is let's go ahead and plug in our value of number of months, 50 times 12 plus 60. So that's 600 plus 60 equals $660. So our graph kind of misled us on this. We should be able to read the graph and get at least a decent idea as long as we've made a good scale of what our value is going to be. This time we ended up kind of being off by quite a bit, and we were better off plugging this into the actual value. So be sure to take the time to complete the note summary on the back page. 3 things I learned today, 2 things I want to know more about, and 1 big question that I still have. Then at the bottom of that page, you can make sketches, graphic organizer, connections to other classes.